Hello everyone. So today we're going to be graphing piecewise functions. So hopefully this video, if you watch it, helps you explain a lot of the stuff that you need to know about graphing these functions. So overall, they're not that bad. And just before we begin, I want to go ahead and say that, reminder of what a piecewise function is. It's pretty much a set of functions that went ahead and were restricted so they don't overlap. So let's go ahead and look at this one. I got x squared and I got x plus 2. The easiest way to do it is to go ahead and remember how your parent functions look like. You can pretty much use transformations. But if you don't remember what the parent functions look like, you can pretty much do an XY table that I'm going to do right here and just put random values. So let's go ahead and graph this. So I got this function right here, x squared, and I'm just going to put a couple of values in here. Let's say, sure, -2, -1, 0, 1, and 2. And those are my x values. So if I substitute them into my y's, I get -2 squared. So it's -2 times -2, right? Which gives me 4. The next one's -1. -1 times -1 gives me 1. 0 squared, right? Because we're putting it into this function right here, the x squared. This gives me 0. 1 squared gives me 1. And 2 squared gives me 4. Easy peasy. Okay. What we're going to go ahead and do is just graph it. So these are my x values. These are my y's. So at -2, I got a 4 in height. So -2, I got 1, 2, 3, 4 in height. So it gives me that. The next one says -1 and 1. So 1 to the left, 1 up. Okay. The next point says 0, 0. The next point says 1, 1. And then the next one, 2, 4. So 2 to the right, 4 up. Okay, the next thing that we're going to go ahead and do is we're going to go ahead and trace that. So the best that I can looks something like that. That's pretty bad, but it still looks like a quadratic, if you will. Okay, the next thing is I got an x plus 2. So let me go ahead and pick those values. Sure, why not? Let's go ahead and do the same values. Okay. But ideally, it's completely up to you what numbers you pick. I just pick some negatives, pick some positives, and you're good. Ideally, a little pattern will show, which is a parent function. So same thing here, we get the x's, we substitute them. So -2 plus 2, that's 0. -1 plus 2, that gives me a +1. 0 plus 2 gives me 2. 1 plus 2 gives me 3. And 2 plus 2 gives me 4. And I do the same thing. I just pretty much graph it. -2, right? Because this is my first point. -2, 0. -2 left and 0 in height. The next one says x is -1, y is 1, so -1 and +1, so I got something like that. And the next one says 0 and 2. Next one says 1 and 3 in height. And next one says 2 and 4 in height, something like that. And since it is linear, you should see something like a y equals mx plus b, which is the linear parent function. Okay, so this is what I want you to know. We have these two graphs, and just like I mentioned, if f was just one complete function, right? Just how we saw the other day. And they told us, hey, this is a function. Hopefully you're able to see that, hey, this right here, guys, it's not passing the vertical line test. So what we're going to go ahead and do is we're going to limit the domain, and therefore we're going to be able to split that graph up so it can be a function. So oops. So as we see, like it's still and I'll show it tomorrow in the presentation, but it overlaps, so therefore it can't be a function. They're two separate functions. So this is for my students in class, but these are like heads up of like how the week looks like and stuff like that. Okay, so something very important that you guys need to know is right here. And I encourage you to write this down on your notebook. So you'll see this whenever the function is restricted. It looks like this. It'll give you some function, and then it has these little restrictions that I like to call them. So when x is greater than a, what does that really mean to you? Okay, so remember this little symbol looks like a Pac-Man to me, and it looks like x is greater than a. So meaning, if this was a number line, right, because the easiest way to do it is if a was right here, x is greater than a, that means everything bigger than a, right? Bigger than a. Or if you're looking at a number line, to the right of a. Okay. Now, when x is less than a, remember the Pac-Man eats the bigger number. So this would be stuff that are less than a, so stuff that are smaller. So like less than a or left, right? The value is left of a. Okay. Similarly, these right here have a bar. That's just pretty much telling you equals to. So hopefully you can fill that out by yourself. Go ahead and pause the video, fill it out, and then I'll show you that answer. Okay, so x greater than or equal to a, so right, bigger than or equal to a. So a is included out here. So right, including a, right of a. So pretty much when we're graphing these guys, this would be like a solid dot on the function, on that point. And then the same thing goes here. This one is to the left. That is less than or equal to. Okay. All right. So when you're graphing, this is very important. There's going to be a point where you have to find out what is the height at A. So whenever it does not have a bar like these ones, the top two, this is going to be like an open dot. Okay. So both of these are going to be open dot. And when it has the bar, like these two, it's going to be a solid dot. It's going to be a solid dot at the height of A. So pretty much A will be your X value and the height will be your F of A. You'll pretty much see that right now. Okay, so like a nice little visual. So let's say you have these two, and this is pretty much what we're going to do. You can graph it. If you know parent functions, guys, you're ahead of the game. That's awesome. If you don't, you can just make an XY table. It's not that bad. It just takes a little bit longer, but you'll still be good. X squared plus 1 and x minus 1. So you can just pretty much know the shapes by the parent functions. So x squared, guys, gives you the happy face parabola, and the x gives you your linear, just like your parent functions of and then, sorry, the y equals mx plus b. So the next thing you need to do is find where the restriction is. And like I said, it's just that x equals 0, and I'm sorry, x less than 0 and x greater than or equal to 0. So keep in mind, it's just an example, just pretty much foreshadowing what we're going to see. So I like to limit the domain there, just like on Rumbling. And you just pretty much graph them, guys, like that. So x squared plus 1 is a parabola. Let's shift up 1 unit to up. And since we are working with only x less than 0, right? I'm only going to keep what is true. So only this part right here. Everything else, guys, it doesn't exist. You don't have to solve for it. And then the next one is x minus 1. That is a linear. Oops. And the same thing. I only want what is greater than. So anything to the right. Just how we saw in the previous slides, the previous notes. And ta-da, that's all we're gonna do. So let's go ahead and try some right now. So we got this right here, and let me hide this right here so I can see my screen. We have x plus 2 and 2x, whoops. Alrighty, so go ahead and pause the video, fill in the tables and plot the points, and I will do the same here. So I'm gonna, it doesn't matter which one you pick, but oops. I'm gonna say that this is x plus 2 and this is 2x. Alrighty. And here's the good stuff. Here is the nice stuff. X is less than -1 and X is greater than or equal to -1. So I'm going to find out where that is, and -1 is right here. And I'm going to make my little dot. Okay. Not to be confused with a vertical asymptote. This is just for references, and I'll erase it later. Okay. So I do the same thing. I want all the values that are less than -1. So I'm going to go ahead and put them. For my reference, I'm going to leave this as -1. And I want all the numbers that are less than, aka to the left, right? To the left of X equals -1, right? So all the values here. So I'm going to pick -1, -2, screw it, -3. I think by then I'll figure out the pattern. Okay. The next one says this one, X is greater than or equal to -1. So again, -1 and all the values that are greater than, so that are bigger, I'm going to say that's to the right. Right, so -1, what's bigger than -1? 0, 1, 2, and I think by then we'll figure out a pattern. Okay. Alrighty, so all you have to do, guys, is substitute these x's into here and solve. So -1 plus 2, that is 1. -2 plus 2, that's 0. And -3 plus 2, that is -1. So now you have x, y values, just plot them. I'm going to go ahead and do this function with, let's go ahead and go with green. So this function will be green. So x plus 2. I got a point right here, -1 and 1, -1 and 1. Now, very careful, guys. I want to fill in this solid dot, but keep in mind, it is not included in my thing, so I'm going to leave it open. Everything else will be solid. Okay, the next point says -2 and 0, so -2 is right here, 2 to the left, because this is my origin, right? So, sorry, that's my axis, so -2 is 2 to the left, and 0, so I'm going to go ahead and make that dot right here. And the next is -3 and -1, so something like that. If you still don't see the pattern, you could probably do another one, -4, and I go ahead and see it. That's -2, and I can see that there's like a pattern going like a little line with a slope. So this right here is my graph for x plus 1. Alrighty, let's go ahead and try the next one. And let me go ahead and do this with purple. 2x, so I'm going to get that -1. I put it into here and I substitute. So 2 times -1, -2. 0 times 2 is 0. 1 times 2 is 2. And 2 times 2 is 4. Okay. Before you begin, remember the restriction said that it was equal to, right? So this is going to be a solid dot. So -1 and -2. So -1 and -2 tells me it is below right here. So I'll make that dot nice and solid. The next point that I have is this one right here. My x is 0, my y is 0, so I got a dot right here. The next point that I have is 1 to the right, 2 up, so like so. And hopefully you're starting to see a little pattern. And then 2 and 4 up. So just like that, guys, this is how we graph a piecewise function. And if you know your parent functions, guys, you can probably see that, oh, there's a linear 2 units up, and there's a linear that has been vertically stretched by 2, you know. If not, we'll learn that throughout the weeks to come. Okay, let's try the next one. Same thing, guys. Go ahead and see the restriction. I like to put it at -1, so I'm going to go ahead and see that this is -1. X equals -1. And then I'm going to decide. This right here says it is less than or equal to. So everything less than, is it to the left or to the right? It's to the left, right? Because all the numbers less than -1, which is -2, -3, -10,000, -infinity, stuff like that. So to the left is going to be x minus 3. And that must mean that this right here, when x is greater than -1, that's going to be right. X is greater than, it means numbers bigger. So like 0, 2, 7, 12, 10,000, positive infinity, stuff like that. So this is -x squared. Okay. Similarly, you go ahead and do the same thing. You're pretty much going to pick numbers I always include this one for a reference point, x equals -1, and x plus 3 is talking about stuff to the left. So what is numbers to the left of -1? So in a number line, I get to think it's going to be -2, -3, and so forth, as many as you need. Eventually, you just get to see the pattern. -4 if you want. It's fine with me. And you just substitute these x's into here. So -1 minus 3, that's -4. -2 minus 3, that just makes it more negative, guys. -5. -3 minus 3, that's -6. If negatives make it confusing, just think about it. I got -$3 minus $3 more. That just makes stuff more negatives, you know? You owe more money. Okay, -4 minus 3, that just makes it more negative. That is -7. And all you have to do is plot these points, -1 and -4, 1, 2, 3, 4. Okay, keep in mind this one is right here. This one has the greater than or equal to sign, so actually I can fill this in. Lucky me. Okay, and then you just keep doing the same thing. 2 and -5. Ooh, these are very, very low numbers. And then 3 and -6, but you can pretty much catch my drift, right? It looks like that. Okay, the next one is -x squared, and it's all the values, including, I'm sorry, not including, but let's use it as a reference, -1, and all the values to the right. So 0, 1, 2, stuff like that. So when I get -1, I substitute it. This one looks a little tricky. I'm going to write it out. -1 squared. So that negative turns positive, but it's still 1. So -1 times -1 is still 1. And then it just makes it negative. Ooh, you try to trick us. So the next one, -0 squared. That is just -0, which is still 0. The next one says it's -1 squared. That is still 1. And -2 squared. Keep in mind the negative was on the outside. So that's -4. So all we're going to do is plot these points. So I got -1, -1. So -1, -1. I'm going to leave it open because you can only have one solid dot. The next point is 0, 0. Those I can make solid. And I got 1, 1. Those I can make solid. Everything else will be solid. And 2, -4. 2, -4. Jump down over here. 1, 2, 3, 4. Sorry about that. So ideally we should have something like so. Yeah. So all I have to do is connect these graphs like so. Okay. Something looks funny too, but I can't see it. Oh, there it is. This was a negative. There you go. Sorry about that. I was like, something looks funny. Sorry about that. So what I did here is I forgot my negative on my 1. So I squared the 1, but I forgot to put it here. So there you go. That looks prettier. And I should have seen it sooner because it's a parabola that's been reflected. So it should have been a sad face parabola like that. And it just keeps on going this way. Awesome. So that's another example of a piecewise function. It looks pretty nasty. The only thing I want to stamp here is that this right here, the restriction, when I say there can only be one solid dot, I mean specifically here. Everything else will be a solid dot. Just here, you can only have one solid dot. And I know a lot of kids want to make that other open, but it's not because it was not included in that value. Okay. Alrighty. Last example. Same thing goes. I go ahead and find out which one of these are my restrictions. Okay. So let's go ahead and see this real quick. It says I have a restriction at x is less than -1, so I'm going to find it. Oh, I really made everything -1. I need to change things up. Okay, oh yeah, because the graph was small. Okay, so this is x equals -1. And the other restriction says from 2. So when x equals 2, so this one right here is x equals 2, right? Because there's 2 to the right. Okay, so what I want you to know is that the exact same thing occurs. You're going to go ahead and find out, oh, this right here, when x is less than 1, that's on the left, right? So this is going to be x plus 2. The next one says this right here, -1 to 2. All the numbers, including 1, all the way to 2. So between -1 and 2. And 2 is not included, but we're going to put it as a reference. So this is 2x. And last but not least, let me use red. Everything that is 2 to infinity, right? This is to the right. Okay, and this is just 3. That's very interesting. We're going to talk about that tomorrow also, since I know I did give a couple of troubles. Okay, so let's go ahead and do this. Pick numbers for this one. Pick numbers, and we agreed it was to the left. So pick numbers that are to the left of -1. And we put -1 as a reference, guys. Always, always, always. So -1, what is to the left of -1? That's just more negative. So -2, -3, and we should be good. If not, you could do -4 if you wish. And all we have to do is substitute them. So -1 plus 2, that just gives me 1. -2 plus 2, that's negative plus positive, 0. -3 plus 2, that's just -1. And -4 plus 2, that is -2. Okay, just think about it like you owe $4, you make a $2 payment, you still owe $2, right? And let's go ahead and graph this. Something I like to do before is that I need to notice that this -1 and this 1, I don't have the bar under it, so therefore they have to be open. So -1 and 1 is a point right here, and I'm gonna leave it open. The next one's -2 and 0. Everything else should be closed. -3 and -1. The next one says -4, so 4 to the left and 2 down. And I have this pretty nice little linear function like so. Okay, the next one says, let me pick a different marker and I'll do dark blue. It says between -1 and 2, so -1 and 2. Ooh, nice, there's only 2 numbers there. And all I do is substitute them, nothing new. So 2 times -1, that's -2. And 2 times 2 is 4. And all I do is plot those points. But keep in mind there is an equal sign right there in the bar. So therefore this one has to have the solid dot on -1 and 2. -1 is 1 to the left and 2 up. Oh, sorry, 2 down. Whoa, caught me slipping. So here this will be a solid dot. And then, did I forget 0 and 1? Oh wow, guys, I don't know what's going on with me. So 0, 1, and 2. I don't know what happened. So we have 0 times 2, that's 0. This is 2, and 2 times 2 is 4. I don't know what happened, guys. Okay. Sorry, I guess I'm getting nervous and class is about to start. Okay. So the next point is 0, 0. Nice at the origin. Way to go. 1 and 2. So 1 to right, 2 up. And 2 and 4. So 2 to right, 4 up. 1, 2, 3, 4. So we have this nice, pretty little thing. And I forgot that the 2 does not go solid. It stays open. So yeah. So we have something like so. Remember, we can only make it solid if they have the bars, right? So in this case, only -1 had the bar and 2 did not. 2 was completely empty, right? Okay. The last one says to the right. So my last one says it is greater than 2. So everything to the right of 2. So 2, 3, 4, 5. And look, it says 3. So no matter what you do, guys, and there's no x, it's always going to be 3. So this is 3, this is 3, this is 3, this is 3. And if they told us 10,125, it'll also be 3. So you find out that everything will be 3. For my y values, so at 2, it is 1, 2, 3 in height, and everything will be 3. forever and ever and ever. Okay. So whenever you see something like this, it is always 3. So super easy stuff. All right, so this is my piecewise function. We did do a couple mistakes, but it's okay. That's how we learn, right? And I believe that's all I have for you. Alrighty, just when you watch this is the only mistake that we were making. Okay, thank you for sticking with us, and as always, it was a pleasure. See you guys tomorrow. Peace.